Climate change and its impact on biodiversity, a review of current knowledge and future directions. Abstract: climate change is one of the most significant threats to biodiversity worldwide. It is already causing changes in the distribution and abundance of species, altering ecosystem functioning, and threatening the provision of ecosystem services. This review summarizes current knowledge on the impacts of climate change on biodiversity and identifies future research directions to improve our understanding of this complex issue. We discuss the direct and indirect effects of climate change on species and ecosystems, including changes in phenology, range shifts, altered community composition, and increased extinction risk. We also highlight the potential for climate-driven interactions with other stressors, such as habitat loss and fragmentation, invasive species, and pollution. Finally, we discuss the importance of interdisciplinary research, the need for large-scale monitoring programs, and the development of conservation strategies that are adaptive to climate change. Introduction: climate change is a global phenomenon that is caused by human activities, primarily the burning of fossil fuels and land use change. The resulting increase in atmospheric greenhouse gas concentrations has led to a warming of the planet, changes in precipitation patterns, and an increase in extreme weather events. These changes are having profound impacts on biodiversity, the variety of life on Earth. Biodiversity is essential for ecosystem functioning and the provision of ecosystem services, such as pollination, pest control, and water purification. In this review, we summarize current knowledge on the impacts of climate change on biodiversity, including direct and indirect effects, and discuss future research directions to improve our understanding of this complex issue. Direct effects of climate change on biodiversity: climate change is causing changes in the timing of seasonal events, such as flowering and migration, which can disrupt species interactions and alter ecosystem functioning. For example, in the Arctic, the earlier onset of spring is causing a mismatch between the timing of plant growth and the arrival of migratory birds, leading to declines in bird populations. Climate change is also causing range shifts, as species move to track their preferred climate conditions. In some cases, species may be unable to move fast enough, leading to local extinctions. For example, the mountain pine beetle is now able to survive in warmer conditions, leading to an increase in outbreaks that are killing vast areas of pine forest in western North America. Indirect effects of climate change on biodiversity: climate change can also interact with other stressors, such as habitat loss and fragmentation, invasive species, and pollution, leading to compounded impacts on biodiversity. For example, warming temperatures may increase the spread and impact of invasive species, such as the Asian tiger mosquito, which can transmit diseases to humans and wildlife. Climate change can also exacerbate the impacts of habitat loss and fragmentation, which are already major threats to biodiversity worldwide. Future directions: to improve our understanding of the impacts of climate change on biodiversity, it is essential to develop interdisciplinary research programs that integrate ecological, physiological, and evolutionary perspectives. Large-scale monitoring programs are also needed to track changes in species and ecosystems over time and identify areas of high vulnerability. Finally, we need to develop conservation strategies that are adaptive to climate change, such as assisted migration, habitat restoration, and the development of climate-smart protected area networks. Conclusion: climate change is already having profound impacts on biodiversity worldwide, and these impacts are likely to increase in the coming decades. To address this complex issue, we need to develop interdisciplinary research programs, large-scale monitoring programs, and conservation strategies that are adaptive to climate change. By doing so, we can help to mitigate the impacts of climate change on biodiversity and ensure the continued provision of ecosystem services essential to human well-being.